If I were using the textbook to teach this lesson, this would be in Chapter 1, Section 7. It's called Absolute Value Equations and Inequalities. Now, as you're taking notes or watching the video, feel free to pause the video and write extra things or watch. I do suggest that you both listen and write things down because I think you retain more. So, you know what an equation is. It's something that has an equal sign. So for instance, I could have an expression that looks like this. X could be anything, but once I put an equal sign and a number here, that narrows it down to X being just one specific number. So that's an equation. An inequality is different. An inequality uses the symbol less than, greater than, less than or equal to, less than or equal to, or greater than or equal to. So let's just do a quick review. I know you did this in Algebra 1, but if I were to talk about X being greater than or equal to 3, the solutions for this, just like the solution up here, would be subtract 3, it'd be 7, so it'd be 3.5. With what would work for X. Here there's lots of numbers that would be solutions for X. 4 would be a solution, 5 would be a solution, 6 would be a solution, 3 would also be a solution because it's equal to. So if I graph this, I'm going to graph the number 3 on my number line, and since it has an equal to 3, I'm going to put a closed circle here. And the numbers that work for X are all the numbers bigger than 3, and the numbers bigger than 3 lie on the right side of the number line, so I'm going to shade to the right. What about if I wanted to shade or graph t is less than -1? I would graph -1 on my number line. And since -1 is not a solution, I would make an open circle, and then all the numbers less than -1 would be to the left. What about if I graphed this? 5 is less than X. I'm going to have 5 on the number line. Now look at where X is located this time. X is on the right side of this inequality. So I'm looking for X to be numbers bigger than 5. And those numbers bigger than 5 are to the right. Sometimes in elementary, teachers teach and students learn that you always shade the direction of the arrow. It works on this case. It works in this case, but it doesn't work in this case because notice X is on the right side of my symbol. So I always want to look at where X is in relation to the symbol and shade accordingly. Sometimes you'll talk about a compound inequality. Excuse me. And a compound inequality looks like this. The numbers that are solutions have to meet both qualifications. The numbers that are solutions have to be bigger than -1, but they have to be smaller than 3 as well. So that would look something like this. -1 does not work, so open circle. 3 does work, close circle. And then X is all the ones in between. So it fits both of these qualifications at the same time. If it doesn't fit both qualifications at the same time, it's called an or inequality, and it looks like this. X is less than or equal to -1, or X is greater than 3. Here, you could find numbers that would be smaller than 3 and bigger than -1, but if you write this one out, if a number is smaller than -1, there's no way it could be bigger than 3. So this kind of graph is an or compound inequality, and it looks like this. Smaller than or equal to -1, or bigger than 3. It can't be both at the same time. It's one or the other. So let's go ahead and move on then and talk about solving inequalities. I want to remind you how to solve. So let's do one that's 2x plus 7 is less than 11. And let's do one where it's -2x plus 7 is greater than or equal to 11. So to solve an inequality, you're going to solve it just like there was an equal sign there. So I'm going to subtract 7 from both sides and divide by 2. So if I graph this one, shade everything on the side. And that makes sense. Let's think about a number that's in that solution set, like 1. 2 times 1 is 2. 2 plus 7 is 9. 9 is smaller than 11. So all the numbers shaded should actually work in our inequality. Let's look up at this one. Subtract 7 from both sides. So I get negative 2x is greater than or equal to 4. And here's where I want to remind you that whenever you divide by a negative number, and you probably did some proof of this in Algebra 1, when you divide by a negative number, you have to reverse the sign. So in this case, I have negative 2, and all the numbers smaller than negative 2. If we hadn't reversed the sign, we would have got a solution set that wasn't true. Like if I try the number 3 over here, 2 times 3 is negative 6. Negative 6 plus 7 is 1, and 1 is not greater than 11. So we know the numbers over here don't work. Had we not reversed the sign, we would not get the correct solution. So remember, anytime you divide by a negative number, you have to reverse the symbol.